Welcome back, guys. So today we'll be learning geometric intuition of vector. In the last couple of videos, we learned about vectors and the dot products. So now in this video, we'll learn about geometric intuition of vectors. So how can we represent vectors on a coordinate graph? So let's say if there is a vector given x1 comma t, and let's example it's 3 comma 4. So so this is a point x comma y, right? So we can represent it on a graph. Let's say 3 or 4 somewhere here. Now what we can do is for origin we can take a line, and so this is called a line segment, or this is a vector from origin, and this is how we can define the geometric. Now, what is the geometric meaning of dot? So, given that, let's say I have a vector, let's say I have two vectors, A and B. Oh, dot. So, let's say I have two vectors, A with x1, y1, and I have a vector B with x3, y. Now, these vectors, as we said earlier, will be from the origin, so they will meet, right? At origin they can hit. Now, imagine there is a light source on top of A. There is a light source on the top of A, vector A, and the shadow will be formed on B by vector A, is called it. So, if we draw a straight line from here, this will be the shadow casted on B by vector A. So, this is the representation of dot product. This shadow casted is the representation of dot product. Now, what will be the length of this? So we can say that since the whole length is B, so we can define this length of this as log. So the this part, to get this part of the length, we can say that A dot B vector divided by log of B. So this is the length of B. Okay. So this is a geometric interpretation. How can you think about it? We'll derive the formula later, but this is just to now. And in similar way, if we tilt our graph and put uh, a light source on top of B, and it will cast a shadow on A, and whatever uh, shadow will be falling on A, it will be part of. You can define it as a dot product. But to understand this more, let's solve a question. Given 2 points, minus 1 comma 2 and 4 comma 2, what will be the dot product of this? So given that, so it will be something like minus 1, 4, 2 and 2. This will come out as C. Now, understand this. When will be the dot product U? Right? If you use this as a representation here, when will be the this value, D value will be 0. So if you think intuitively, as we increase the angle theta, the value of A will keep on decreasing. And on 90 degree, this value will be 0. Value of D will be 0. As the shadow cast here will fall on 0 on Z. Okay. So if if A is perpendicular to P, A dot B will be 0. The dot product of two vectors will be 0 if both vectors are perpendicular to each other. Okay. Now another topic we will look into is distance between two points. Whether we will use all these topics to solve our original problem. If you remember, if you have not gone through the first two videos, please go through them. And this is all prerequisite we are learning to solve that original problem. Please stay a little bit patient and we'll get through. Well, you'll see all the dots will be connected. Okay, coming back here. So distance between 2 points. So let's say if you are given 2 points on a coordinate geometric plane. So this is our plane and this is our point. Let me draw it again. So this is our plane. This is A, and A is x1, y1, and this is V. This is x2, y2. Now we want to calculate distance between A and this distance. Now how can we calculate it? Let's see. So if you think here, this distance, if you want to get what it will be. Okay? So this will be x2 and this will be x1. So this distance will be x2 minus x1. Right? Again, similarly here, let's say draw it. That so this is y2 and x4 x1 and x2. But this distance will be y2 minus y1 and here it will be x2 minus x1. Right? Okay, now this is an 90 degree. So this distance is y2 minus y1 and this distance is x2 minus x1. So now can you calculate this distance? It is easy, right? So using Pythagoras theorem, we can say d square is equals to x2 minus x1 square plus y2 minus y1 square. And we do a root square. This is also called as Euclidean distance. Now if we take the same logic and given a vector x1 comma y1, what will be the distance from origin? 0, 0. So if we say that calculate the distance of a vector A from origin, we will use a formula. and yeah, just the uh, it is from origin. Form equation will look something like this. Okay, so you can also say that d square is equals to x1 square plus y1 square. Another way to represent this is in form of matrix, where we can say x1 and y1 into xn and y1. Right? This is correct. Right? Now, this we can represent, if you remember, as vector A, and this is also another same vector. So we can say that the distance between uh, origin and vector A is A vector dot n their both. So this notation, uh, so there is a this notation is also called as norm or magnitude of vector. So this is the distance we can calculate of vector, any vector, and we can represent it also by something like this. So if I write it, it means that the magnitude of the vector or the distance of the vector from the origin. Now, can we calculate the distance between 2 points? Let's say if I give you 2 points, 3, 4 and 7, 7, what will be the distance between them? Okay, it's a simple one. Please write the answers in the comments. Moving on, I want you to find the difference between the norm of 6, 8 and magnitude of 3, 4. Please pause the video and try to solve this. Okay. So let's try to solve this. So the norm we said that it is the magnitude. So we can calculate it by 6 square plus 8 square, which gives us 36 plus 64, 100, which gives us 10. And the second one is 3 square plus 4 square, which gives us 9 plus 16, root of 25. Right. So to calculate, we want the difference between them. So 10 minus 5 and 5. So this is our answer. Okay. So keep practicing these kind of questions, so it will make your concept much more stronger. Okay, let's moving on the next topic, which is angle between two vectors. Now let's say you are given again a vector A and vector B, and these are passing from the origin. By default, we'll make we assume that it is from the origin, vector B. Okay. Now I want to calculate the phi, this angle, right? So this angle will be, let's say this is theta 1 and this is theta 2. So we can say that phi will be theta 1 minus theta 2. So now to calculate this value, phi value, let's remove this part, only this part. Okay. And let's see how can we proceed with that. So let's say here is our something like this. So here again our vector A and vector B, and we want to calculate this y. And this is the shadow casted by A on B, which makes sense since it's perpendicular on the beginning. Now this distance, what it will be? It will be magnitude of vector A, which we represent as, okay. And this distance we already saw. This dot product between A and B divided by normal. Okay. So now, so we have done all this. Now we want to calculate the y. So if you remember a little bit of trigonometry, where we say that, let's say, given a triangle, let's say this is our triangle, it says degree and this is theta, and this is A, B, and C. So for this, our tan theta will be B by C, correct? And our cos theta will be adjacent by hypotenuse, right? Now, using this equation or this value cos theta, can we get the cos theta here? So we can say cos phi is equals to adjacent, which is this part, in dot being now being into hypotenuse, which is our norm of A. Okay. Now this is what we'll use in for further uh, learnings. So yeah, that's it for today's video, and we'll meet in next. In there, we'll learn about more about like decision boundary. Like we'll discuss more on the types of lines and vectors. Right? So yeah, keep learning and meet you in the next video. Bye.